Hello, welcome to my differential calculus course. Now, in this presentation, I will have a specific example for the first derivative test. Now, here we go to ChatGPT and ask him, could you generate for us a specific example for our first derivative test? And here's the outline of it. So, we should know about the maxima and the minima, and I have provided a video to give you a short description of what a maxima and a minima is. But essentially, a maxima and minima are critical points where the first derivative is set to 0 or it's set to be undefined. Now, if the transition of the first derivative is from positive to negative as we traverse the graph or the curve from the left to right side, and the first derivative or the slope of the tangent line to the curve changes in sign from positive to negative, then there is a local maximum. Conversely, there's a local minimum if the first derivative or the tangent to the curve changes from left to right such that it is negative to positive this time. If there's no change in sign, then there is no extremum, so no maximum and minimum. And let's try to show that by having a specific example this time. So we try to download the graph generated by ChatGPT, and here we have it. So all we need to do is to copy everything. Then let's try to paste it in a note. For those of you who haven't watched my previous video, let me try to give you a first glimpse of what it looks like so that our discussion will flow on smoothly. Now, in the first derivative test, as you can see, we have a maximum point here. So let me increase the size of my pen. So here we have a relative or local maximum in this point. So this corresponds to xn, and as we see, if we traverse this curve from left to right, there's a transition of the tangent line. So as you can see, the tangent line from positive slowly it's what is happening here is slowly the tangent line is its inclination is decreasing. So as you go along with it, it is now relatively flat. Hence we have a slope which is equivalent to 0. Now as we go on further, we see that there's a decline in the inclination of the tangent line, and after a while we see that the tangent line here for a decreasing part of the curve, it's less than 0, or this is negative. Okay, so again, in the first part, from increasing, which is positive, the value of the first derivative is positive for an increasing part of the curve, then the inclination relatively goes down, becomes flat, and becomes the slope is essentially 0, and then after a while there's a further decline, so you have something like less than 0, so it's essentially decreasing. So we see that from positive to negative, the value has to go through 0, so the first derivative there at the critical point is essentially 0, and then we have a local maximum. Naturally, the converse is true. If we go from a negative, as you see, it's negative in value, to positive, then positive here. From the left side, then it's getting less negative, so until it reaches this point wherein the slope is essentially again 0. Then after a while, we see that the inclination increases until it reaches some positive value. But in summary, for you to go to a transition from negative to positive, then you have no choice but to go through 0. And once you pass the 0, we can identify that as a critical point. And corresponding to the critical point, we see that every point is above the local minimum. Hence, we have a local minimum in this region. So all we need to do is to set the first derivative to 0. So let's have a specific example. So here we have the graph of x cubed minus 3x squared. Now all we have to do now is we try to take first the first derivative. So the first derivative is, so let's try to write it first. Y equals x cubed minus 3x squared plus 2. Now the first derivative now, we identify that to be something like 3x squared minus 3 multiplied by 2x. So the first derivative here is, we have to bring down from the formula y x to the n. So we have to bring down the to get the first derivative, we have to bring down the exponent and then subtract 1 to the exponent. So this is essentially 3 multiplied by x, 3 minus 1, so that's 2. So this is minus 3 multiplied by, we have to bring down the exponent 2, and then x, 2 minus 1, which is essentially x. However here, so plus 2, so we have something like, we have a constant here, no variable, so it's essentially 0. So your y prime now is 3x squared minus 6x. That's your y prime. Now, all you need to do now is to set the first derivative to 0. So assuming y prime is equivalent to 0, then all you need to do is to factor the 3 and the x. So y prime is 3x multiplied by x squared, x minus 2 equals 0. 3x equals 0, or x equals 0, and the other one is x minus 2 equals 0, or x equals 2. And do you see that in the graph? Yes. As you can see now, we have a relative maximum at 0. So this one is a maximum. And a local minimum at 2. So again, how do we decide if there's a maximum at x equals 0? So all we need to do is to consider the points here. So if we have tangent lines drawn to the left and to the right, we can see from the graph that there's a transition from positive to negative. But can we verify that? So from the first derivative, so in the left side, so we try to substitute a value in the left side for 0. Say for example negative 1, try negative 1. Try x equals negative 1 to the left, and we see that what's the value for the first derivative? So that is 3 multiplied by negative 1 squared minus 6 multiplied by negative 1. Therefore we have 3 plus 6 which is 9, and it is positive. So indeed, in the left hand region, in the left, it is positive. And let's try to the right side. So let us agree on the value. So for example, x equals in the right side, for example, 1. So y prime equals 3 multiplied by 1 squared minus 6 multiplied by 1, and hence what do we have here? So that's essentially 3 minus 6, or negative 3, which is a negative number. And yes, we have a negative number here to the right side. So if there's a transition from positive to negative, then truly we have a local maximum. Okay, now let's try it for the other side. Now we already know that in the left side of 2, the values there are negative. So we have already tried that. So here we have tried 1. So that's correct. So to the right side, or to the left side of 2, okay, the value here is negative. So here in this side, from the left of 2, from the left of 2, the value is negative. So let's try to examine to the right of 2. So let's agree again on the value. So we have to try, for example, let's try 3. X equals 3. Therefore y prime is 3 multiplied by 3 squared minus 6 multiplied by 3, and we have something like 27. This is essentially 9, and this is 3. So 27 minus 18. Okay, and 27 minus 18 will give you a positive number, and that's correct. The value here is positive to the right side of 2. So again we have something like, so again we have this region 1, and this one is region 2. Okay, so here in region 2, again the transition is from negative to positive. So truly, here in region 2, we have a relative, we have a local minimum. As we can see here, we have a minimum and a maximum here at region 1. So in the next presentation, I will show to you how do we test for if the graph is concaving downward, or something like it concaves upward, and that is with respect to the second derivative test. But for now, that's all, and thank you.